Hello guys, welcome back to my YouTube channel. So our topic for today is conic sections, introduction to parabolas. So this is the real life example of a parabola. Do you remember this curve? We had seen this curve back when we were in grade 8 and 9. Okay, so when we say parabola, so this is the name of the curve. This is the set of all points that are equidistant from a fixed point and a fixed line. So it means to say that the distance between the focus and the vertex should be equal with the distance between the vertex and the directrix. In order to form a parabola in terms of slicing the cone, it must be parallel with the edge of the cone. Okay, so we're now going to discuss the terms to know, also known as the parts of the parabola. When we say focus, it is the fixed point of the parabola. So this is the focus. When we say the latus rectum, it is a chord that passes through the focus. So when we say the vertex, it is either the maximum or the minimum point of the parabola. So when we say the directrix, it is the fixed line of the parabola. When we say the axis of symmetry, it is the axis where the vertex lies, like as well as focus too. Okay, so now we're going to discuss the vertical parabolas. As we see that these are the two types. If your P is greater than 0, then it opens upward. If the P is less than 0, then the parabola opens downward. So the P is the distance between the vertex and the focus, or the distance between the vertex and the directrix. So the vertex is also known as H and K, right? So we all know it right now. So in order to find the focus, we'll just copy the x-coordinate of the vertex. However, what are we going to do is we're going to add the y-coordinate k with p. We're just going to add k and p in order to get the y-coordinate for the focus. In order to get the directrix, we'll just subtract the y-coordinate k with p. So the side of the or position of the directrix is horizontal. Okay, the axis of symmetry must be vertical because it intersects the focus and the vertex. Okay, so in order to get the axis of symmetry, we can get the value of x in the vertex, from the vertex. Okay, so in order to get the endpoints of the latus rectum, we need to copy the y coordinate of the focus. So the coordinates for the endpoints of the latus rectum are the same with the focus in terms of y. So it means to say that the y coordinates of the endpoints of the latus rectum are the same with the focus. However, there are differences with the x coordinates. For the first pair, for the first endpoint, what are we going to do is we're going to subtract h with 2p. However, for the second endpoint, for the x-coordinate, we have to add h with 2p. Okay? So, that is how we find the parts of the vertical parabolas. When we say horizontal parabolas, okay, so this is y squared already, right? So we see the difference. A while ago, in the vertical parabolas, it was x squared, while here it is y squared. Okay, so if your p is less than 0, it opens left. The parabola opens left. If your p is greater than 0, then it opens right. So the vertex is the same as is. However, there are differences. Okay, so in finding the focus, your y-coordinate should be the same as the vertex. So k lang siya talaga. Left or right. However, if you're going to find the x-coordinate of the focus, what are you going to do is you're going to add h with p. So the x-coordinate h with p must add together. Okay? Regardless of the sign of the value of p. So in order to get the directrix, so the directrix is vertical for the horizontal parabolas. Well, the axis of symmetry of the parabolas must be horizontal. Okay. So in order to get the axis of symmetry of the horizontal parabolas, then your y must be k. So in order to find the directrix, you will have to subtract h with p. That h comes from the x coordinate of the vertex. So in order to get the latus rectum endpoints for the horizontal parabolas, okay, so the x coordinate of the focus must be equal to the x coordinate for each endpoint. So it must be the same in terms of x coordinates. However, there are differences in terms of y coordinates. So all you have to do with k is to add with 2p for the first endpoint in terms of y coordinate. For the second endpoint, all you have to do is to subtract k with 2p, okay? In terms of the second pair of the coordinates, or this is just for y, okay? So that for p is the length of the lattice rectum. Okay, so now we're going to perform the examples of different parabolas. Okay, so first step is to identify if the parabola is horizontal or vertical. To identify if it is horizontal or vertical, we need to know if there's x squared or y squared. If we have only x squared, then the parabola is vertical. If we have y squared, then our parabola is horizontal. So since we have x squared, it is vertical. So we can recall the standard form of the vertical parabola. Okay, so our vertex of the parabola is h and k. Okay, so in order to look for h, we're going to relate x minus h with x. So using the subtraction property of equality, we're going to subtract x both sides. Okay, so what will happen is x minus x is equal to 0. So therefore, h will be automatically 0. In order to look for for k, we're going to relate y plus 1 with y minus k. So what are we going to do is to use the subtraction property of equality to subtract both sides by y to remove the y. So what will remain is 1 and negative k. Since these have opposite signs, divide both sides by negative. So our k is equal to negative 1. So our vertex is 0 and negative 1. So in order to get the focus, we have to retain the value of x. However, what are we going to do is we're going to add k with p. So in order to look for p, we're going to equate 4p with negative 16. So in order to look for p, divide both sides by 4. So negative 16 divided by 4 is negative 4. Okay, so our h is 0, then our k is negative 1. What are we going to do is to add with the value of p. Okay, so positive times negative is equal to minus. So negative 1 minus 4 is negative 5. Okay, so that is the focus for this parabola. Okay, so since RP is negative, then it opens downward. In order to look for the directrix, okay, so it must be Y because it is horizontal. Okay, so what are we going to do is to subtract K with P. So our K is negative 1, then our P is negative 4. Okay, so we substitute. So what will happen, since a double negative is positive, so negative 1 plus 4 is 3. So therefore, our Y is equal to 3. In order to get the axis of symmetry, since this is vertical, it intersects the focus and the vertex. What are we going to do is to get the value of x from the vertex. So our x is equal to 0. So that is the axis of symmetry. In order to get the latus rectum endpoints, okay, so we're going to retain the y coordinates of the focus. But before that, we need to say that h plus 2p, then k plus p, and h minus 2p, then k plus p. Okay, so what are we going to do here is we're going to substitute the respective values. So 0 plus 2 times negative 4. Then 0 minus 2 times negative 4. So what are we going to do is to simplify. So 0 minus 8 is negative 8. Okay, 0 plus 8 is 8. So we can say that these are the latus rectum endpoints. In order to get the latus rectum, we need to find the difference of the x-coordinates. So 8 minus negative 8. So we need to find the difference of the x-coordinates of the latus rectum endpoints to get the latus rectum. So 8 minus negative 8 is 16. So the absolute value of 4p is the latus rectum, which is 16. Okay, so now we're going to move to the next example. Okay, so now we're going to identify the vertex. Again, it's always hk. Okay, so in order to look for the vertex, we're going to relate x is equal to 4, then x is equal to h. Okay, to make it shortcut, so since both have x and both have negative sign, we can easily tell that our h is 4. Then for k, y minus k is equal to y minus 5. Okay, so since they have both y on both sides and the minus sign, so we can easily say that our k is 5. Okay, then okay, so since this is x squared, we can say that it is vertical parabola. Okay, so our focus is the same since it is the vertical parabola. Okay, so in order to get for the p, we need to equate 4p with 8. So divide both sides by 4, then rp is equal to 2. So what are we going to do is to substitute according to the values. So 5 plus 2 is equal to 7. So our focus is 4 and 7. In order to get the directrix, okay, so y equals k minus p. So what are we going to do is subtract the value of k along with the value of p. So 5 minus 2 is equal to 3. So therefore, our y is equal to 3. That is the directrix of the parabola. So since our p is positive, this parabola opens upwards. So in order to get the axis of symmetry, we can get the value of x here. So this must lie on the vertex and the focus. So that's how we get the axis of symmetry. In order to get the latus rectum endpoints, okay, so we're going to write the formula. Okay, so our h is 0, is 4. So all we have to do is to substitute. Then our p is 2, substitute pa rin. Then our k is equal to 5. Then our p is equal to 2. And our h is 4 plus 2 times 2. Then our k is 5. Then our p is 2. Okay, so what are we going to do is to simplify. 4 minus 4 kasi 2 times 2. Then, likewise with the second pair. So, the endpoints are 0 and negative 7 and 8 and 7. In order to get the latus rectum, we have to subtract the x-coordinates. So 8 minus 0, which is 8. So the latus rectum for this parabola is 8. So in our next example, since we have y squared, we can say that this is a horizontal parabola. So we're going to equate y minus k with y minus 6. So since, okay, our vertex is h and k, we can say that our k is 6 because it's two identical, right? However, since both signs are opposite, so our trick is negative, then our h is 2. That's why our h is negative 2. Okay, so a while ago, why our k is positive 6? Because of the same sign and the same y. So we can say that our k is 6. If the h and 2 have different signs, then we can say that our h is negative. So in order to look for the focus, so what are we going to do is to retain the value of k, since this is a horizontal parabola. So h plus p. Okay, in order to look for p, we're going to equate 4p is equal to 12. So dividing both sides by 4, we can tell that our p is equal to 3. So we're going to substitute according to the values of h, p, and k. So negative 2 plus 3 is 1. Then our k is equal to 6. So since our p is positive or greater than 0, that it opens right. So our directrix is vertical. We can write x is equal to h minus p. So what are we going to do with h is to substitute with negative 2 and our p with negative 3. So negative 2 minus 3 is negative 5. So our x is equal to negative 5. So that is the directrix for this parabola. In order to get the axis of symmetry, okay, we can familiarize from the y coordinates from the vertex and focus respectively. So we can say that our y is equal to 6. Take note that the axis of symmetry for the horizontal parabola is horizontal, while the directrix for the horizontal parabola is vertical. While for the vertical parabolas naman, our axis of symmetry is vertical while the directrix is horizontal. Okay, so in order to get the latus rectum endpoints, so we're going to retain the values of x for the focus. However, we're going to subtract k with 2p for the y for the first pair. While for the second pair, we're going to add k with 2p. So we're going to substitute now. Okay, so computing, negative 2 plus 3 is 1. While 6 minus 2 times 3, so 2 times 3 is 6, right? So 6 minus 6 is 0. And negative 2 plus 3 is 1. Then 6 plus 2 times 3, okay, so 2 times 3 is equal to 6. So 6 plus 6 is equal to 12. So we're now, in order to find the latus rectum, we're going to subtract the y coordinate. So 12 minus 0 is equal to 12. So this is the latus rectum for this parabola. Keep in mind that the absolute value of 4p is the latus rectum for each parabola. So last but not the least, okay, so now since we have y squared, we can tell that the parabola is horizontal. So now we're going to equate y minus k with y plus 5 in order to get the k of the vertex. So our k for the vertex is, from the vertex is negative 5. Why? Because of the opposite signs. Okay? So since we just have x here, so x minus h is equal to x. Since this has no number here, so we can tell that our h is 0. So therefore, our vertex is 0 and negative 5. In order to get the focus, okay, so what are we going to do is do the same thing to retain the value of k, then h plus p. Okay, so now we're going to equate to look for the p. So we're going to equate 4p with negative 20. So divide both sides by 4. So RP is negative 5. So since RP is negative, then the parabola opens left. So what are we going to do is subtract 0 with negative 5, then RK with negative 5. So 0 minus 5 is negative 5, then RK is negative 5. So that is the focus. This is the focus for this parabola. In order to get the directrix, okay, so our directrix is vertical. Okay, so we can write x. So x is equal to h minus p. So our h is 0, then our p is negative 5. So we can tell that 0 plus 5 is equal to 5. So our x is equal to 5. So that is the directrix for the parabola. In terms of the axis of symmetry, we can get the value of y from the vertex, which is y is equal to negative 5. In order to get the latus rectum, okay, so what are we going to do is to find the endpoints. So we're going to retain the x-coordinates of the focus, subtract k with 2p, and on the other pair, we're going to add k with 2p. Okay, so now we're going to substitute. We're going to substitute according to its respective values. Now we're going to simplify 0 minus 5 is negative 5. Then negative 5 minus 2 times negative 5 is, so 2 times negative 5 is negative 10. However, negative 2 times negative 5 is plus 10. And 0 minus 5 is negative 5. Then negative 2 times, 2 times negative 5 is negative 10. Okay, so now we're going to simplify. So negative 5 plus 10 is 5. And negative 5 minus 10 is negative 15. So now we're going to find the difference between the y-coordinates. So 5 minus negative 15 is 20. So that is the latus rectum for the parabola. So thank you guys. Do not forget to subscribe my channel. Do not forget also to like my videos and do not forget to click the bell button. Thank you and God bless.